Hey everybody, Mr. Judson here. So today we're going to talk about implicit differentiation, which everything we've done so far is categorized as explicit differentiation. It means that we can get y by itself and take the derivative. But the question we want to talk about is what happens when you can't get y by itself? So what happens if I have an expression that looks like this? 2xy plus 4y squared equals 3x minus y. It would be pretty hard to solve this equation for y. But taking the derivative of it isn't hard. All right? So here's the thing. I learned this new method probably about, 10, 12 years ago, where I quit teaching the way the book teaches. So you probably don't want to read this section in the book, if you're someone who does that. Because you won't find what I'm going to teach you guys today. It's a different method. I learned at a workshop from a lady who had been teaching calculus for a long time, and it's so much easier than the way the book just teaches us how to do it. Okay? So here's what we're going to do. Every time I take the derivative of something, I'm going to put either a dy or a dx after it. Whatever variable it is, I just took the derivative of. All right? So when I look at this term right here, I'm multiplying these two things, and so what I'm going to have to do is a product rule. Here's the first part, here's the second. So when I take the derivatives, I'm going to take the derivative of the first piece, which would be 2, times the second piece, and the variable I just took the derivative of is an x variable. So I'm going to put a dx here. Okay? Think of that dx as just one variable. It's not d times x, it's dx, which means that's what I just took the derivative of. Okay? And then plus, leave the first piece the way it is, and take the derivative of the y variable, which that derivative would be 1, and I just took the derivative of y. Derivative of that would be 8y, and I just took the derivative of a y variable, and that should equal 3. Just took the derivative of x, minus the derivative of that would be 1, and I just took the derivative of a y variable. Okay? Now, remember, when you take a derivative, dy over dx means the same thing as y prime. That's what I want to try and do. I want to get dy over dx. So what I'm going to do is I'm going to put all of the dy stuff on one side of the equal sign and the dx stuff on the other side. So let's see, since I've already got two terms here, I'll just go ahead and leave the dy stuff here. 2x dy plus 8y dy. I'll bring this over, it'll become positive 1 dy. On this side of the equal sign, I've got 3 dx, and I got to take this term and move it to the other side and do the opposite. That will become negative. So minus 2y dx. And then my next step is going to be to factor all the dy's and dx's out. Okay, since I got all the dy's on this side, I'll factor out a dy, and what I have is 2x plus 8y plus 1. On this side, I'll factor a dx out, and I've got 3 minus 2y. And now my last step is I just want to see dy over dx. So my dy is right here. I'll bring this dx over and divide. And here I'm multiplying dy times this, so if I move this set of parentheses to the other side, I have to divide by that. So 3 minus 2y over 2x plus 8y plus 1. There's my derivative. So the one thing that's different is my answer has both x and y variables in it. That means if someone asks me a question like, what's the slope of the tangent line? Well, I'm going to need an x and a y coordinate to plug into this. So you would hope they would give you both of those. If they don't, if they just give you an x value, well then I got to plug that in up here and then solve for y. I would have to solve a quadratic equation to be able to do that. Okay? So if we look at our steps here, the first thing we're going to do is we're going to take the derivative and then we're going to put dy's and dx's in there. Now remember, this is only something that we do when you can't get y by itself. If I could have solved this equation for y and said y equals a bunch of stuff with x's, well then I'm just going to go and use my rules that I have already. Product rule, quotient rule, whatever I need to use. But if I can't do that, then I have to do this form of implicit differentiation. So I'm going to take the derivative, I'll put dy's and dx's in, that's what I did right here. Call that step 1. Step 2, I want to get dy terms on one side and dx terms on the other side. Okay, that's what I did right here. Now, I'll be honest, I usually skip this step and go from here straight to here, because if every term has a dy in it, I know my next step is to factor it out. Why not just do it at the same time? Okay? You don't have to do that, but if you want to make this a little bit shorter, you can. Once I get that dy and dx factored out, well then it's just a matter of move this over here and divide, move this over and divide, and you've got your answer. Okay, so let's see, I'm going to say factor out dy's and dx's. And then fourth thing is find dy over dx. That's our derivative. Okay. It's interesting. The way I used to teach it is the way our book does. And by the time we got to the end of the day, everybody was frazzled. I was breaking out in a sweat. Nobody would get it. It was frustrating. And everybody left frustrated. But once I started using this new method, probably 2 examples in, people were like, got it. Got it. This is a piece of cake. What's next? So anyway, hopefully you guys will feel like this is pretty easy. Let me get you guys a problem. All right, so you guys go ahead and try this one. All right, so if I take the derivative of this, I've got 8x, and I just took the derivative of x. We've got to make sure we put that one piece in there. Minus 3, just took the derivative of y. Over here, I'm multiplying 2 things. And it doesn't matter if you put the 2 with the x or with the y. I just always leave it with the x because that's where it was. So I'm going to take the derivative of the first piece, which is 2, times y. And I just took the derivative of an x variable. Plus, leave that 2x the way it is. Derivative of y, that'll be just 1. And I just took the derivative of y. So now I want to get my dy stuff on one side, dx on the other. Since that dy is already positive, this one's negative. If I move it over, both of those will be positive. That's probably a good thing. So I've got 2x dy plus 3 dy. I'll move this term back over here, and I've got 8x dx minus 2y dx. Now I could have, at the same time I was moving things back and forth, I just know dx is going to cancel out, so I really could have just done this. I've got 8x. I'm moving this 2y over, so it becomes the opposite. See, I could have thought of it that way instead of doing this and then factoring. But it doesn't matter, whatever you feel more comfortable with. Over here I've got dy times 2x plus 3. And so I want dy over dx, so I'm going to move this dx over here to divide. And that means to get this by itself, I got to move that 2x plus 3 over here. So 8x minus 2y divided by 2x plus 3. There's my derivative. Let's try another. Yeah, so this equation is kind of interesting. If you were to graph this, the graph looks something like that. I only know that because there was a picture of it in our book. But yeah, if I want to find the derivative of this, which this, by the way, is not a function. It doesn't pass the vertical line test, right? That means there's no way you could solve and get y by itself. But we could still talk about the slope of a tangent line at different points along this curve. Okay, so you guys go ahead and try this one. See if you can find the derivative of that equation. All right, so this would be 3y squared. Just took the derivative of y. Plus 2y, I just took the derivative of y again. Minus 5, and I just took the derivative of y. Minus 2x, just took the derivative of x, and the derivative of that would be 0. So all these terms have a dy in it. I'm going to go ahead and factor that out. I'm left with 3y squared plus 2y minus 5. And I'll move this term to the other side of the equal sign. So I've got 2x dx. And we're trying to find the derivative, so we want dy over dx. So I'm going to bring this dx over and divide. And then I got to get rid of this. I'm multiplying here, so I got to move that whole thing over and divide. So 2x over 3y squared plus 2y minus 5. And there it is. We found the derivative. So this process isn't hard. It isn't long. We just need to make sure we understand it. Okay? Which is not the way it used to be. I really like this method. It's a good one. All right, so what if we had to find the slope of the tangent line? So we want to, we'll just call this part B. Find the slope of the tangent line at 1, negative 3. Well, since we have an x and a y value, all we got to do is plug it back in and we've got that. Right? You guys go ahead and find that slope. All right, so our slope, if I plug in a 1 for x, I've got 2 in the numerator. In the denominator, I'm plugging in a negative 3, so that would be 9 times 3, that's 27, plus 6, minus 5. And so that's going to be 2 over 28, or 1/14. There's the slope of our tangent line. And so if they would have said find the equation of the tangent line, well then I've got y minus the y value equals the slope times x minus the x value. All right, let's try one more. All right, so here I've got x squared plus 4y squared equals 4. And they want us to find the slope at root 2 comma negative root 2 over 2. Now, first of all, when I look at this, I could probably solve this for y pretty easily. Okay? When I take this, I'll move this over, I'll divide by 4, and I'll take the square root. But when I do that, I got to remember that y equals plus or minus the square root. I'm not sure which square root I should use, the positive one or the negative one, because I don't know which one goes through that point. But if I just do this implicitly, then I'll be fine. I don't have to worry about it at all. Okay? So I would not try to solve for y if I didn't have to. I would just go ahead and do this implicitly. You guys give it a shot. All right, so 2x, and I just took the derivative of x, plus 8y, and I just took the derivative of y. That would equal 0. I'll go ahead and leave my dy term here. I'll move the dx to the other side. So I've got 8y dy equals a negative 2x dx. And now to get dy over dx, I'll bring the dx back. I'll move the 8y over here and divide. I know that's going to reduce down to a negative 1 over 4, but I'm just going to go ahead and plug the numbers in right now and see what I get. So I'm going to get a negative 2 times the square root of 2 over 8 times a negative root 2 over 2. And so in this fraction right here, 8 divided by 2 is 4. I know a negative divided by a negative is positive, so what I really have is 2 root 2 over 4 root 2. The root 2's cancel, and then that reduces down to 1/2. There's my slope of the tangent line at that point. All right, that's it. That's what we have for today. Implicit differentiation. Based on what we saw here, this doesn't seem like it's very hard, and that's what I like about this new technique. But again, this is one of those things that every time we learn something new, they're going to say, now do the derivative implicitly. You know, so this is an idea that'll stick with us for a while. All right, let me get you guys an assignment. All right, so let's see. For tonight, we've got still part of number 10, week 10. We're doing page 149. We're going to do 9 to 14, 25, 29, and 30. And this would be our Wednesday portion. All right, that's it. You guys take care, stay safe. I will see you on Thursday. Goodbye.